See Lindelof videos, analyze a polynomial function. Let's see if I have it all right this time. We have f of x is equal to the opposite of 2 times x squared times the quantity x squared minus 2. And we decided this time what we do is we'd look at the function first and see if we can make sense of why it does what it does. So here is the function. This is what it does. We see that it has an intercept at x is equal to 0, but if you see it goes down, it touches it, it goes back up, it never passes through the function. But here and here it does pass through the function, so maybe try to figure out why that's all true. So go back here, it says we're asked to list each real zero and its multiplicity. Well, one thing I would do here is this. I would look at this negative 2 here. I would look at this as if it was x plus 0 squared. So maybe you can see where that first 0 came from. So if I brought this out and I said, when is x plus 0 equal to 0? That would be true when x is, well, equal to 0. Are we good with that? The question of a multiplicity comes from the exponential value, and the exponential value is 2. Here is 2, this 2. So it has a multiplicity of 2, right? Multiplicity of 2. Then I'm going to pull this second factor down, this x squared minus 2, set that equal to 0. So we get x squared is equal to 2. This is where I almost screwed this up. Take the square root of both sides. Square root of x squared is x. The square root of 2 is plus or minus the square root of 2. Everybody cool with that? The multiplicity is what? Multiplicity of 1, because this is to the first power here. That's where we get our multiplicity. Right? So that answers the first question. The second question is determine whether the graph touches or passes through the x-axis at those intercepts. Well, at x is equal to 0, based on what we can conclude from multiplicity, if the multiplicity is even, then it touches the x-axis. Only, that is to say, it touches it, but it does not pass through it, right? We look at the next one, though. This one has a multiplicity of 1. And if it has a multiplicity of 1, if its multiplicity met is an odd number, we know it passes through at that real 0. And the real 0 is plus or minus square root 2. So we have x is equal to square root 2. X is equal to opposite square root 2. Multiplicity of 1, it passes through. Right? So it passes through x-axis. That is to say, all the way through. It doesn't just touch it, goes through to the other side. It goes from positive to negative or negative to positive. Right? That gets us there. The next point is we have to determine the max number of turning points, which is actually pretty easy also. What we do is we look for its power function. Kyle, all that means is if we expanded this whole thing out, what is the variable with the highest exponent? It would be an x to the 4th power, wouldn't it? In this case, it would be negative 2x to the 4th power. Can you see it? So its power function is equal to negative 2x to the 4th power. How many times can it turn? Well, to the power function's exponent minus 1, right? That's the rule. So this could turn 3 times. I want to say this again to you. It doesn't mean it's going to turn 3 times. You should not say to your professor, oh, it's going to turn 3 times. That's not what it says. It could turn 3 times. And then lastly, we're asked to determine the end behavior. And to determine the end behavior, again, you look at the power function. We know that quartic functions, x to the 4th powers, look kind of like this, don't they? This function has an opposite sign in front of it, so it flips that thing over, doesn't it? So our function is going to look like this. And we can actually draw this out a little bit, right? Because we know that this is the point x is equal to 0, isn't it? This is the point x is equal to opposite of 2 squared. This is the point, I'm sorry, square root 2, isn't it? So we're asked to evaluate end behavior. Well, what is this? Remember, when we ask for end behavior, you're going to answer it twice. The first answer is going to be as x approaches positive infinity, Well, as x approaches positive infinity, you answer the question, f of x approaches what? And as we move this way, and we're stuck on the function, what's the graph doing? It's diving really hard, isn't it? So it's approaching negative infinity. The second time you write it similar to the first. You say, as x approaches, but instead of positive infinity, negative infinity. So that means we're moving this way. F of x approaches negative infinity.